examples should be old news to you because you did general solutions last year. So I'm just going to walk through them. You can make notes on your notes if there's something that you want to put in. Okay, the question will always be solve theta or solve A or solve whatever. And they give you an equation. In this case, they also give you a range of theta. So it's going to be from minus 90 degrees up to 90 degrees. And that will be in those two quadrants. I have a cos plus sin. What is that? Cos with a minus. Remember, it changes the sign. That will be equal to 0.715. This is what you write here, and your reference angle will be that one. So the cos of boogkos of that is 44, and you write all the digits because this is not the final answer. Just waking up, please. So in the first quadrant, theta minus 24 degrees will be equal to this one plus k times 360. Why is it 360? Because it's cos. The cos period is 360. Then you take the minus 24 degrees over to the right hand side, so it becomes a plus 24, and you plus it only here. And remember your k element of z. Or, no?
Am I allowed to round off already by the reference angle? Like once you get it, once you round off there, we'll just keep all the decimals.
I wouldn't round off there. I will keep the decimals because it's not the final answer. Now we look at the fourth quadrant. Again, you write the angle that's in the brackets on the left hand side. And in the fourth quadrant, it's 360 minus the reference angle plus k times 360.
Let's say in the range that they give us from negative 1 from 10.
Yeah.
The range.
Okay, then we add the 24, subtract the 44, and we get your final answer. But they gave us a range. So we need to work out k. If k is negative 1 and you put k in there, you'll get an answer which doesn't fall in that range. So it's not applicable. If k is 0, you get the final answer. Now you test the k with negative 1 in the other option as well. Again, you get another answer which falls into the range. And if you substitute it with 0, this also falls out of the range. So your final answer only has 2 degrees. You can just type it.
So also have to show the not applicable ones. Wouldn't have to show the ones that don't count.
No, the ones that are not applicable.
You don't have to show them.
No.
Should there be some judgment?
Okay. Example 2. Do you want to go through all the examples? And record it. All the examples. Alright. The next one. Good choice. The next one is if cos of an angle is half of a sine. Ooh, this one is difficult. Neat. I take the half of a sine over to the left hand side. Neat. I expanded that. Cos minus sin equals half of a sine. Then I multiply with 2 to get rid of the half. And then you end up with a cos equals to a sine. you want a tan, you have to divide with cos. So this becomes a tan. And now I divide by 2 to get the other side of the equal sign.
So, ma'am, you see, with the 30, whenever we get a special angle from the beginning, should we change it?
Yeah, that's to get this answer. So now I have tan of an angle equals square root 3 over 2. Yes. Then maybe you can get a trinomial, which you can further factorize. Right. Now they've asked you hence. Hence means use the previous answer. Hence find the general solution. So I'm going to use that. You find your reference angle, write all the digits. Tan is positive in those two quadrants, the first and the third quadrant. So you have two answers here, and you get your answer. Why don't I do the table again here with K? They don't give you a range. Right. The next example is find the solution, the general solution for this equation.
That was another question. So like when you see the sign of which quadrant you're gonna work with for general solution, you see that just before you're about to get the reference angle.
Yes.
So you actually do everything, but
Yes.
just before you get the reference, that's the sign.
Yes.
Those are the quadrants.
Yes. Okay, this one, I take the 3 over to the left-hand side, and now I have a trinomial. You factorize that, and now you have two sums to work on. The first bracket equals 0, or the second bracket equals 0. The first bracket, sine of an angle, is minus 1.5. If you look at the sine graph, does it ever get 1.5? No, so there is no solution. Sine must be between minus 1 and 1. So minus 1.5 is no solution. Yeah?
Where are we?
This one. If you take the 3 over, okay? The other one,
And so when is it that you use the graph and basically this happens?
if you see that you have a sine of a normal angle, theta or alpha or whatever.
Just sine and then angle.
Yeah.
Okay.
And you see you've got a negative, not a negative 1 or a 0 or a 1, then it's no solution.
Not a negative 1.
If you type in sine minus 1 of 1.5, you'll get error. The next one, I see that I have a sine that is equal to 1. So where is the sine graph equal to 1? Only at 90 degrees. So my reference angle is 90 degrees, and I have one answer. Okay, are you with me? Are you awake? Wide awake. Error. Then, the next example, I say find the general solution. And now I have cos 2 alpha. That is a double angle. So it's 2 cos squared minus 1 plus that one. And if you add them, you can't add them. You get a trinomial and you factorize. Again, you have two answers, two brackets that equal 0. In this case, cos is a half.
And how do you know when to use which cos double
Because I'm giving this many of this. Okay. I see from there that I have another term with cos. And I look at all the options of the double angle of cos. The one is cos squared and sine squared, the other one is 2 sine squared, and the other one is 2 cos squared. So, if I use the 2 cos squared, I have a cos, the middle term, and the third term, so that will be my trinomial. So I chose that spot. Okay, so you have to look further. If let's say I didn't see that I need to use this one, if I use another one, would it work out? You might get stuck and then try another one. Okay, you didn't take this one, you get stuck again. So you're actually going to waste time. So rather look a little bit further into the sum. Right. Two brackets multiplied gives me 0. So either the one bracket is 0 or the other bracket is 0. If cos alpha is a half, it's positive. So it's in the first or the fourth quadrant, you get your two answers. If cos is negative 1, it's only at one place, it's 180 degrees, so you get your answer. And then you have to look at all your answers. If you have doubles, if you don't, you can just draw your lines to show the marker that you know these are the three possible options. Okay, next one. Determine the general solution for cos 3x equals sine x. If the angles are not the same size, this one is 3x and this one is x, you can't make it a tan. Then you have to use the co-function, the little fairy. Alright, cos is positive in the first and the fourth quadrant. Now the 3x stands on the left hand side and this is your reference angle. And you get your answer. Or in the fourth quadrant, the 3x stands on the left hand side and what is in the bracket is your reference angle and you work out your final answer. Are you all with me? The next one. Find the general solution for sine of a compound angle equals to negative cos. Sine and a cos is used. The angles are not the same, so I have to use co-functions. Okay? So where is sine negative in these two quadrants? The angle on the left is the angle on the left. The angle in the bracket on the right is your reference angle. And you get your two answers. Any questions here? Last example. Find the general solution for sine 2 alpha equals 2 sine alpha. There is a double angle, so I expand it. And now I take out the common factor.
Example 2a.
Huh?
So example 2a. Example 2a.
Okay, did you all find them? Yes. I expand the sine 2 alpha, then I take out 2 sine alpha as a common factor. Again, you have two things that you multiply, which is 0. So either the first one is 0 or the bracket is 0. Then you work out the first one, your reference angle, where is sine 0 at 0 degrees and 180 degrees. Or where is cos negative 1 at 180 degrees, and there's your answer. Here I have a double, can you see? And another one. So then you have to conclude, it's that one or that one. Okay.
Or if these two are the same, you just have to.
Yeah. There's a double. So now you have to conclude it's that one or that one. Okay, any questions with general solutions?
If you skip the middle and you write the reference angles and that final answer, will you do the math?
If you skip the middle,
So you write the reference angle is 0 and the reference angle is 180 and then you straight to the bottom.
yeah,
That's K alpha is equal
you
to
leave out that one.
yeah,
That's fine. All right, that's the last lesson of the previous quarter term.